lovely day?
It's cold. Thank
It's
you.
cold. Isn't it cool? Of course snow feels cold, right?
I hate stuff.
A little bit, really?
I like
Not even
snow.
the first snow?
That's a bad idea.
Everybody likes the first snow.
Yeah, but
I
we
like
gotta shovel it.
snow on Christmas.
Dude, this snow will be heavy this
No, it's not steam, right? No Christmas.
Okay,
Merry Christmas.
my original schedule had a test planned for Thursday, but I didn't know about the PSAT and the juniors being gone, and I have a decent amount of juniors. So I'm going to move the test to next Tuesday. Your test will be next Tuesday, and instead,
We have to be there Wednesday. We have to be here Wednesday. Of course we do.
yeah,
So
it's not the way we
I
It's
know.
not like every other
awful.
year.
Only at
Dog,
It's
right?
only at
No, I
What
think
they say, put it on Friday, it'd be a great day for seniors to go visit colleges, or Friday and Monday, maybe the
Because usually if we had the day off, of course.
Yeah, it was always everyone got the day off, except now that we would get.
What? They didn't get it off that?
Yeah, they did.
At any rate. It is funny because I didn't know what or be a better respect. Okay. Yeah, sign a petition. I'm sure it'll do a lot to good. Anywho, the lesson for today is pretty straightforward. It'll go quickly. I want to sum up or make sure the hyperbolic thing went well. And then we'll get to questions, and we'll be all caught up today. Yay! Okay, so logarithmic differentiation, as it kind of indicates, it'll be taking derivatives with logs. Some of it is really intuitive. When we covered the derivative of exponentials, like 2 to the x, we went at it a certain way. Do you remember what it was before we just memorized it?
Took the ln of both sides.
Yeah, you took the natural log of both sides.
Yeah, I heard it say ln.
Oh, you said Lynn.
What good does that do? What good does that do you? It allows you to use the log rules of bringing the x down out of the exponent. That really is the problem. When you have a variable in the exponent, that's a problem. You deal with it almost always by logs, and it is often a problem that you encounter. All right, so after that, am I done? Did I do the problem? No, I've done pre-calculus. At this point, I now need to do calculus. What is the derivative on the left? 1 over y dy dx equals natural log of 2. After that, I isolate dy dx, and that is y natural log of 2. Sub back for y, and that is 2 to the x times the natural log of 2. All right? Now that is very much the process when things are slightly more complicated, like x to the x. This is a really intense function. Exponential grows fast anyway, but this is base growing and exponent growing. It's one of the fastest growing functions there is. Try to differentiate it. Tell me what you get for the derivative of that using logarithmic differentiation. Did you get something like 1 plus natural log of x, that quantity times x to the x? Okay, so that is the proper way to do it, and that is the answer. It might surprise you, it doesn't surprise me, but the most common answer when this comes, this is not a huge idea of calculus. It's one multiple choice question usually on the test. And a common error to this would be the most common, in fact, the most common answer would not be the right answer, it would be that one. What is that person thinking? They're applying the power rule to the derivative. They're saying, oh, I just bring the exponent down and reduce it by 1. So I bring x down, reduce it by 1. They're using the power rule. Power rule is not to be used on a variable exponent. Okay, no power rule on variable exponent. When you have anything to a variable, that's a no-no. It's only when you have to a constant that is to be done. I gotta say this, I might have gone a little overkill on this. I think these two, that one's under homework. That one's not really necessary. Would you please do this one first, and then this one? That one is pretty darn hard. That one, I think if you get the idea, it should go well. Try the last one, then the third one. What do you think? Are we agreeing roughly with that last one? Is that about what you had? Talk to me, people. Okay, you got a product rule on the inside, and the 2 to the x gets sub 4 back at the end, and so something like that. If that's what you have, then you're on the right track. Keep going and play around and think and work together on the last one. The last one is a little harder. It's got a little wrinkle to it. I'll let you think about it. I don't want to hand it to you. I'd rather you come up with it on your own. Or with your amigos. Are you making headway?
Yep.
Good.
Well, I'm sorry. Figuring it out. I'll just stop
We're
trying.
just bitter because we're.
Try use it. You just use up the term inside. Change tangent to
So you're saying just do it
tangent
separately,
to
that's.
yeah.
Yeah.
Just do it separately. Okay. Then why are you mad at me? Because you suck. Who hasn't finished the problem yet? That is irrelevant. And for some.
Just because you're smart doesn't mean you don't suck.
Yeah, exactly.
Wait.
Oh, yeah, that's right. I guess now everyone.
Quentin sucks.
Hi, Mom.
Everyone watches.
Why would you need one
What's big? Well, I didn't understand the calculus very well. Can you show me what I did wrong?
Should I hold on to this till tomorrow? She's not here.
No, I've never had this. I should be around you more. Answer me that. I disagree. What else have I kids? Hold on, I almost have it. Yeah, come on. That's true.
Please. All right. Are we getting there? So, would you agree that the problem is the exponential is present embedded within it? It's not quite ready for logs. Yeah? I had two different approaches to this. Everybody went one way, and one person went a different way. I was curious to see if the same thing happened. What's one way to go about this?
Use stuff.
Use so. All right, so you're basically compartmentalizing it. That's awesome. So I assume you said, I'm going to take the derivative and the tangent, or the chain rule part of it on the outside is fine, secant squared of x to the 3x squared. But when I get to the derivative of x to the 3x squared, I'm going to go off to the side and do this. Yes? Okay. That way works. Well, so another person said, I don't like that tangent there, so what did they do? They took the arctangent of both sides and then did implicit. It was kind of a cool thing too. So that worked also. Most people did it this way, so let's go this way. If I do this, then I start to get a little off to the side. Oops, not yet. Equals 3x squared. 12x. So let me catch up to you. I apologize. 3x squared over x. So here you have something like secant squared of x to the 3x squared. And for the derivative of the inside, you have maybe 3x plus natural log of x times 6x, all times y, which was, in this case, kind of x to the 3x squared. That's what you have? Are we all good? Okay. All right. So there are two ways to use logs. One is, or reasons to use logs. One is if you have a variable in the exponent. In any case, no matter what the base, if you have a variable in the exponent, look to use logs to bring the exponent down. The other is not quite as obvious. People would look at this and think, hey, use logs. If you think about it for a second, though, logs make a lot of sense. If I said to take the derivative on that, what would you think? You cry. Cry is the point. You should cry, okay? Because you have a quotient with a product in the top, product in the bottom, and chains within those products. Holy cow, what a mess, okay? Now, that said, I'm sure you could execute that pretty well because you're pretty good with details, but if there's an easier way, let's do it. Well, logs. Why would logs help you here?
Because you can break it all up.
Yeah, by log rules, if you took the log of both sides, oh, this is good. The log of both sides, by log rules, it seems on the surface like, wow, you just made it more complicated. And yet, if you have the log of a product, can't you write it as the separate log of the sums of each factor? And the log of a quotient can be written as the difference between where anything in the denominator where the divisor is subtracted. Now you might notice that I didn't put the root in there because I can further simplify this by calling it to the 1/2 and moving it down there so that it's all really just the sum of linear logs. Or not linear, I guess those aren't linear, but one factor logs, right? Now we're ready to differentiate. The left-hand side is 1 over y dy dx. And all the derivatives on the right are these simple, easy little log derivatives. What's the first log's derivative? 1 over 2 times x minus 2. Plus the next log term derivative. 4x over 2x squared plus 1 minus negative 1 over 4 minus x minus cosine of x over sine of x, which you might imagine would be written cotangent in the answer. You follow? Okay. Now here's where I cut you some latitude. This amounts to a lot of writing, obviously. Now I need to rewrite that whole thing and move the y over and replace the y, yeah? Now on the homework, I will be okay if you just show me you get the idea, but you cut a little corner here. So wouldn't you say that the derivative, the final derivative will be this thing right there? And let's not rewrite it for the homework, shall we? And then moving y over, and that y, technically on the test, you should sub back for, but you may leave as y on the homework, but on the test, I would expect you to write the whole thing with y replaced. You with me? To which the person in the last class, smart Alex, he says, that doesn't make any sense. On the homework, I have all the time in the world, but on the test, I don't have time. Why would I have to write it on the test when I don't have time to write? To which I have no answer. That's a fine point, but that's the way it is, so deal with it. That's how it is. Rather than make up some manufactured one, why don't you just knock one off the homework, please? I wish I made these boxes long all the way across the board, so write it small. But 9 on the homework is this here problem. Sorry, I had it. I shouldn't have erased it. It's 9 is y equals the square root of x minus 1, x cubed minus 1, sine of x. This actually looks a lot like the one I just did. I made that up on my own. Okay, that is number 9. The question is differentiate. Imagine the consequence of not thinking logarithms on the test. If you didn't think logs on the test and you went quotient or product of the table. Wow. Jesus God. First of all, I'll have to do it that way too with you to check your work. It takes me off. Well, I can definitely do that on the test. And second, you just wasted 5 minutes.
X to the 4.
It's x to the 4th, yes. It looks a bit like a uniform. These two write small. Every term in the denominator should have a negative in front of it. Every term in the numerator should have a positive in front of it. would be better? To show the 1 over y dy dx, or just go straight to dy dx and move the y over at that right away? Oops. So if you showed the right side derivative clearly, and then in the step below that you said that thing, quote, quote, times y, on the homework I'd be okay. Is it clear how to do it and what do I expect? Okay. So today's lesson is logarithmic differentiation, where the 2 times you use logs before derivative. What the case is. If you have a huge product quotient mess, you use log rules to clean it up. And what else? When was the first case? For Pete's sake, people, this is a variable in the exponent. So you can bring the exponent down. Good job. All right. That's that. Do we have on your hyperbolic trig, do you have the 3 big identities, or do you just have the first one? Did we talk about the other 2?
Yes.
Okay, we got that. Do we have all 6 derivatives? Let's make sure you have all 6 derivatives. What's the derivative of sinh? Cosh. What's the derivative of cosh? Sinh. Do you have, in its cleanest possible form, the derivative of hyperbolic tangent? The easiest possible form is hyperbolic secant squared. Or sech, I suppose. You might have an identity equivalent form like tangent minus 1 or tangent plus, what is it, tangent? It would be tangent squared plus whatever. That's the cleanest form. This is the one I want. What is the derivative of hyperbolic cotangent? Negative hyperbolic cosecant squared. Oops, give myself enough room. Squared. Okay. What about, this one is where the signs start to get funky and not normal. What about the derivative of hyperbolic secant? Negative hyperbolic secant hyperbolic tangent, which is a little different than normal trig. Normal trig is just positive, that's negative. And what about the derivative of hyperbolic cosecant? It's also negative. Hyperbolic cosecant, hyperbolic cotangent. Really? Okay. And then with those, hopefully these went fine. First one, 10. Cosh of x plus c. Next, sinh of x plus c. What about this after use of? Natural log of the absolute value of cosh plus c. And then this by calculator estimate is about, what, 2.772? Is that what you said? 762. Like that?
Yeah.
Okay. All right. Well, we did pretty much this whole thing together, yes? And so on cases like that, this will happen once in a while when I teach this class. I don't really see the point in collecting it. You have to be a real loser not to have this done. I mean, we did the whole freaking thing together, right? Oh, we did?
Yeah.
Oh, some of you turned it on Friday. Okay. So if you turned it in, go get it and keep it. I'm just going to put you up for a 10. We're all good. Okay? And that way you'll have it as reference. And it is an assignment I expected you to do, but we did it together, so it should be done already. 82 and 83. What about 82 questions first? What questions do you have on 82?
Number 2, part
2. B?
2, all of it.
2 all of it. 82, 2.
25.
25.
Bash and kick it. I'll get
25, what else?
Try to.
That's what we said, no. 225.
Don't throw it outside. Mike says I want, so I get
One?
here.
Yeah, number one.
One.
I don't know those things.
Okay, here we go. Set 82, number 2. Let's see what we got there. Is that the one with the absolute value?
Rectangle.
Yeah. Okay, this is, it's kind of like, I liken it a little bit to those work ones where we redraw the figure to our advantage. We're going to kind of do the same thing here. This, the maximum of this rectangle is the same as, because there's symmetry, wouldn't it be the same as twice the max of this area? Again, because the absolute value is even and symmetric. So the point is, rather than maximize x, y here and deal with maximizing the absolute value derivative, yuck, by doing this, a prime here would be ugly, yeah? My point is, if I keep the absolute value, then I have to deal with the derivative of the absolute value. It's a big mess. There is absolutely no reason you can't say, I'm just going to treat this like the area is twice that first quadrant region because of the symmetry. That is then easier because the equation of that is an absolute value. It's just the line, 1 minus x. And then you are on your way. Maximize A, find where A prime goes positive to negative. Okay, so you may and should, absolutely. Does that get you going on 2? Okay. Number 25. Ooh, yeah, that's a good one. So you have f of x equals 1 minus sine of x square rooted. How about the domain? Let's start here. I don't know if you need to show all this, but wouldn't you agree that sine is between negative 1 and 1? Inclusive? Yes? Okay. So what about negative sine? Wouldn't it also be between negative 1 and 1? Although technically the sign could switch, but then I could rewrite it. You with me? Are you with me? Okay. Just I'm not trying to make this more complicated. I'm just trying to get some skills in here that'll pay off later. I'm sure you can look at this and just kind of figure this out, but this is how you could show it rigorously. This has a 1 in there. So can I add 1 to each of these pieces? Is that allowed? Yeah. If I add 1 to this, it becomes 0. It's less than or equal to 1 minus sine of x, which is less than or equal to 2. What if I square root? Is equality maintained? It is. Okay, now what I've actually done there is get you the range, darn it. The range is that the function must always be between 0 and root 2. Inclusive or not? Inclusive, okay? If sine goes to a low of, if the low of this could be, the lowest sign could be a 0, negative 1 to 1, then the smallest that thing could be a 0, and the greatest it could be is 2 inside the root. The domain. When I have a root, what's the thing I have to worry about? Negative in a root. Can you get a negative in the root? Why not? 1 minus sine, can it be, if 1 minus sine is negative, then doesn't that imply that sine is greater than 1? And that's not true. And so, can you get a negative in a root? Never. So if there's never a place where I get a negative in the root, then what's the domain? Is there any problem?
No.
So the domain is always. Okay? It's close to having a problem, but it never has a problem. As lowest it gets is 0, and 0 is okay to square root. Okay, one question on 1 is looking at, ye old ladder problem. This is a good one. Classic Calc 1 problem. So you've got a ladder, and a person is climbing up the ladder, and a person down here is pushing it away from the ground. Okay? So that the ladder is sliding down the wall and the person is plummeting towards his injury, right? So then the question is, if they tell you that this guy is pushing the ladder away at something 2 feet per second, at what rate is the angle changing when y equals 5? Let's start with givens. If this is moving away with time, doesn't that imply it's changing with time? So it's got a rate of change. I'll call it x. If it's moving away at 2 feet per second, what does that imply calculus-wise? Dx dt, x is changing with time. Is it increasing or decreasing? Is x increasing or decreasing? It's increasing. That distance will get bigger and bigger. So positive 2 feet per second. They want, how is the angle changing? So that's the theta dt at the instant when this part here, which I'll call y, is 5. Is d theta dt, would you expect d theta dt to be positive or negative? Negative, because that angle is decreasing. All right. So many trig choices to relate, and the Pythagorean theorem. What trig function? Pythagorean theorem or trig function? Trig function. Justify your choice. Why? Yeah, you want d theta dt, so you need some angle action, right? Sine, cosine, tangent, cotangent, cosine. Okay. Cosine because you have dx dt and you have the hypotenuse, so that makes sense. Cosine of theta equals adjacent x over hypotenuse 10. Cool. Differentiate with respect to time. What's the derivative of cosine with respect to time? Theta dt equals 1/10 dx dt. Sub then solve, or solve then sub, whichever you prefer. Do both at the same time. d theta dt is 1/10 of positive 2 times or divided by negative sine theta. Now we need the instant. Golly. At the instant, if I draw the instant here, isn't the hypotenuse always 10? And the instant they talk about is 5. Do I need this side x, or do I have everything I need to say the sine of theta? Feels like that. I have sine theta. What's sine theta? 1/2, right? 5 over 2. I don't need the x side. Sometimes I might have to find it, but I didn't need to here. So at the instant they talk about, I'm looking at 1/5, negative 1 over 10/5, 5/10. So with a little cleanup, negative 1/5 of 2 over 1 is negative 2/5. Last but not least, the units. Whatever. Radians. All calculus is assumed radians, and the time units were seconds. And it is negative like we expected. Okay, roughly a radian. What's one radian about, angle-wise? How big is a radian? Yes. Give me a radian fact. 4. 5 radians, 3-ish radians to 180 degrees. So what's one radian? It's about 50 some degrees, 54, 55 degrees. One radian is about 50 some degrees. Okay? All right. Did you have a question? Yes. 5. Yep. 5. One in. Where did you draw yield axis? Please tell me you drew it at the center of the circle.
I did not.
You didn't?
I did not. That's probably why I got it.
Okay. Now let's do it your way, and then you'll see why your way is so terrible.
Sounds good.
Where did you put your origin? At the bottom of the circle?
I
Or
put it
the...
at the bottom of the circle.
Okay, sounds good. It's not terrible actually. It's give and take, but I think the take is pretty bad. It's 2. Here's the radius, which puts the top at 4, and this is force, not work, right? So force is rho depth area of slices. Rho is probably fine, and that's not an issue. The depth. What's the depth of each slice? Is it 2 minus y or 4 minus y?
So 2 minus 1.
2 minus y is correct. You're fine there. The area, remember that's not the area of the circle, it's the area of these slices. So it's like 2xy.
Yep.
So then the problem then, 2x dy. What's your equation?
So I did x squared plus y squared equals 2 squared, and then I just substitute.
Yeah, so that's the problem. I mean, you put the origin at the bottom. Is that the equation of the circle?
Oh no.
Yeah, so that's why you put the equation of the circle. Your equation would be shifted up, so it would have to be this. And so your equation's ugly. I mean, which is fine. It's not like that's something you can't do. You can do it. 4 minus, so what? 4 minus y minus 2 squared is the positive version. So what you did would work, but that's your x, not the center of it. Okay. Okay. Any others on 82? 83?
Number 10. Or 37.
Sure. Okay. I'm feeling sandwich rule for the next test. How are you feeling? Would you like an ice sandwich for the next test? Yes. Sandwich, yes. F of x equals x squared minus 2. H of x equals negative 2 over x sine of x. And this is actually, I love this question because it's got 2 levels to it, yeah? They tell you f of x is greater than or equal to g of x, which is greater than or equal to h of x, and they want the limit as x goes to 0 of g over x, of g of x, yeah? All right, let's start with what's given. We know this is true. Now that implies then that for every approach in a similar fashion, all the approaching values of each function also should be true. If the first is true, then this must be true. Okay? Now, f of x is defined in their givens as x squared minus 2. The middle part I don't know, that's the question. And h of x is defined as negative 2 sine of x over x. All right. Well, I want to know this. Let's say what it must be less than. What's the limit as x goes to 0 of x squared minus 2? Negative 2. So I know that my answer has to be less than negative 2 or equal to. The right side, a little ugly direct substitution style. It's 0 over 0. What do I do in such an indeterminate case? A hospital or L'Hopital. Okay, now that's cool in that it tells me that that limit must be negative 2. Well, the answer, the question they talk about is less than or equal to negative 2, greater than or equal to negative 2, so the only thing it can be is negative 2. It's getting squeezed, it's getting sandwiched between the two. The limit must be negative 2. Follow? All right, 83. Questions on 83. 8. 5.
25.
25.
21.
21. Doo-doo-doo. So nice to be caught up. Been about a billion years since we did a homework up into this check, huh? We should probably do that. All right, 83. Did I do that homework, by the way? Did homework stats go around?
Yeah, you did.
Okay. 83. 8. 83, 8. How are the old volumes going? I know you're obviously asking about one, so it can't be perfect, but overall, you feeling it-ish? Okay. You should probably do an AP problem or two just to make sure you're on the right track. All right. 80. Number 8. You've got this volume here, and this time it's around the y-axis. So let's sketch. I know they mean at 0 and 1. At 1/2, it would be or actually let's go 1/4. Square root would be on top. So it's something like square root on top, linear on bottom. Okay, if this is revolved around the y-axis, then the reflection of it would be here. But more importantly, a slices reflection. If it's around the y-axis, then you should be revolving horizontal slices. So you're getting washers that look like that. Yay? Okay, I hope by now you know the big idea is big R squared minus little r squared times the height. What's the height? Dx or dy? dy squared. Okay, so that means we're going to write everything in y terms. The outer radius. Seems like the outer radius is always from the axis out to the outer part of the circle is the line each time, yeah? So big R is the distance from the axis to the line. Then in y terms, we just say that is y. Little r is looking at the inner circle and saying, where's the radius? Well, in that case, we're going from the axis to the square root curve. So little r is the axis to the square root curve, but in y terms. So what's, is this the one where I had an error on my key? Is it? Oh, that might be why you had, I have an error on the key. That might be why you're asking about this, yeah. So I think I had square root of y here. Is that what should be there? No, what should it be? If y equals the square root of x, then what is this in terms of y? Should be y squared here. That was an error on my key. That's probably why you're asking about this. It should be y squared there, not square root of y. I don't know what I was thinking. Limits are from 0 to 1. That should then go find y squared minus y to the 4th antiderivatives. Yeah. I apologize for this. Okay. 5. Question of 5. Is 5 still a question? Did somebody ask 5? Yeah. Okay. 5. We need to practice this a little more, I think. Okay, so 1/3 natural log of 1/3 plus natural log of 2/3 plus natural log of 3/3. Boom. Okie dokie. So in each case, you're talking delta x times f at different x's to estimate the area, and infinitely many times then this would become delta dx times the function. Okay, so there's 3 forms really of area under the curve. Expanded form, summation form, and definite integral form. Looking at part A, which is this integral expression for, so it's tempting to say there should be a 3rd in there, right? But the third is just a byproduct of 3 rectangles. Here. An integral is not 3 rectangles. It's just infinite rectangles. So don't think, oh, I need to get it, there's a 3. There's not necessarily 3, all right? What you should focus on, first of all, is what's the region? If you went from 1/3 for a place in which to find the height, 2/3 and 3/3, then you usually ask, all right, are they talking left-hand rectangles or right-hand rectangles? If they were talking right-hand rectangles, then 1/3 would actually be the right interval of each subinterval going by 1/3. And so that tells me it must have been going from a starting of 0 to an end of 1. Yeah? What if it had said left-hand rectangles? Then what would the limits be? One-third to 4/3. 1/3 to 4/3. Okay. They said right hand, so it's 0 to 1. All right. All that's cool. I have that part. Boom. The dx is not to worry. I just need the function. What is the function to which they're plugging all these values in? It's just natural log of x. And the thirds were just a byproduct of their using 3 rectangles. It's not in the actual integral problem. You with me? Part B then is writing this in summation notation. Forget the integral, go back to here. They say write this in summation notation. So I am going to say, all right, I have a third each time, I have a natural log each time, I have parentheses each time, and I have divided by 3 each time. Every one of those is the same. Everyone? And the only thing that's counting, and so I need to attach I to is 1, 2, 3. Identify where the counter or the variation is, and that's where your I will be. The I is just in the numerator. Say what is always the same, put it down. What's counting up, that's the I. Then say what did I start at and go to? What did I start at? 1, and what did it go to? 3. Does that make sense? Okay. The next one was 1/3 root 4/3 5/3. I'm going to call that, rather than root 2, I'm going to establish the pattern and call it 6/3. So I can see the counting and the behavior. All right, if I were to look at this, it looks like 1/3 is each base, which could be a million different places. But in terms of what's inside, I'm starting at 4/3, 5/3, 6/3 for the insides. Which, if each subinterval then was 1/3, then it must have started at 1/3 before 4/3, so it must have started at 3/3. Okay? I write down the points they give me, and then I go back and say, all right, but if each base is 1/3, then the original point must have been 1. That tells me that the limits of integration are from 1 to 2. And inside the function, inside the function is just what's the function each time. Well, that's just square root of x. And again, the thirds are just the fact that they're using 3 rectangles. But it doesn't really mean that infinitely many there will be a 3 in there, does it? All right, summation then, right? What's each time the same? 1/3 is the same, root is the same, over 3 is the same. What's different each time is the numerator. 4, 5, 6 means that's an I. If I have an I there, then what does I start at? 4 and ends at 6. That's one possible solution. What if you are grading this and somebody said, all right, I started I at 1. Then how will this be different? It would have to be I plus 3 to start, and that's fine. It would end at 3. Okay. All right, make sure I get these by the end of the day. If you have the other questions, I will be happy to address them. Just stick around. But otherwise, both do at the end of the day. Bye. Have a great day.